Hello friends, in today's session we are going to see some more interesting uh, collection interfaces and collection frameworks. Okay, so we were looking about array list. So we will continue with that array list remaining part. We will see one array list example so that you will understand what is array list and how it is used. So we will import first util package, then we will create array list of type string. So array list of type string will store all the objects of type string. Okay, and initial size of array list is array list dot size. Then next is add elements to the array list, CAEB. So one by one we will add elements to the array list, and then DF, and at the location 1, that is 0, 1, we will add one element, that is A2. Okay, so first of all, there were no elements in the array list. So initial size of array list was 0. Then after AL additions, size of AL after all additions, it was 7. The contents of array list are C, A2, A, E, B, D, F, and size of AL after deletions 5, and contents of AL are displayed. Okay. A1 starts out empty and grows as elements are added to it, and when elements are removed, its size is reduced. Although the capacity of array list object increases automatically, you can increase the capacity of array list using ensure capacity. Okay, by using the ensure capacity method, you will confirm, or you will tell that the size of array list will be this. Okay, you might want to do this if you know in advance that you will be storing many more items in the collection than it can currently hold. Okay, if you are knowing in advance that there are many more items in the collection other than currently having items, by increasing its capacity once at the start, you can prevent several reallocations later. Okay, so if you are ensuring the capacity at start, so when you are enlarging the capacity at last, so the time complexity and effort complexity you will reduce. Okay, because if suppose, for example, there are 5 elements in the array list initially. Okay, hello, and 5 more are you want to add them, like word. So for hello, there were 5 elements to be added, and you add them one by one without ensuring any capacity. Then again you added word. So your array list size will be automatically enlarged. Okay, for automatically enlarging, what it will do, it will reallocate the memory size. But if you would have been reallocated, if you would have been used the ensure capacity method, your total capacity at start would have been 11. Okay, hello space world. Okay, so in this way you improve your time complexity, that is, you remove your time complexity and effort complexity, and increase your speed of programming. Because reallocations are costly in terms of time, preventing unnecessary ones improves the performance of the project. The signature of ensure capacity is you are passing the integer capacity in the bracket. If you want to reduce the size of the array that underlies an array list object so that it is precisely as large as number of items, call trim to size. Okay. If you want that all the unnecessary extra elements you have ensured, and there are no elements actually present. For example, if you want to store hello world, and actually you are storing hello only, so the size, your index for world, that is location after hello, all the locations are empty, so unnecessarily your array list size is large and there are no items in that. So for that purpose, what you will do, you will trim to particular size, so it will be as large as number of items present. Obtaining array from array list, you will have the you are having the two array method to convert the array list to array. When working with array list, you will sometimes want to obtain actual array that contains the content of the list. By using two array, you can achieve this. Several reasons exist why you might want to convert a collection into arrays, such as to obtain faster processing times for certain operations, to pass an array to a method that is not overloaded to accept a collection. Okay, faster processing time in terms of time complexity. You want the array representation of array list. Again, pass an array to a method. If your method definition is passing the array, not an array list. So what you will do? You will simply convert the array list into array that is not overloaded to accept a collection, to integrate collection based code with legacy code. Okay, so collection based code will always have the array list, but legacy code, that is before collection code, when there were no invention of array list or collections, they were using array only. So if you want to merge the new code with the old code, what you will do? You will convert the array list to array, and that does not understand the collection. Whatever the reason, converting an array list to an array is a trivial matter. Two versions of two array. Object to array, it will give the object array and you will cast it to particular class. Then type T to array, T array returns an array of the elements that have the same type as T. This form is more convenient because it returns the proper type of array. Okay. So when you are passing the array in the bracket, it will return the array of elements that have the same type as T. Okay. So if you want to convert your array, for example, integer type, this T will be replaced by integer. If you want to convert your array list to array of type string, so it will be converted to string and so on. Convert array list to array example, we are creating array list AL and add elements AL dot add 1, 2, 3, 4. Contents of array list are presented or displayed and integer IA is equal to new integer AL dot size. Okay, so what is this? This is the array we have created of particular size of this array list. For example, if your array list is having 1, 2, 3, 4 elements, so your size will be 4 and you will create the array of size 4. Then IA is equal to AL to array and you are passing this IA. Okay, so IA you are passing, its type is integer and then you are converting and storing it into integer array IA. Then sum. What you are doing for integer I colon IA, for each and every element in the integer array, we are fetching it into I, and what we are doing is we are summing it up, like sum is equal to sum plus I. Sum is equal to sum plus 1. Then again sum is equal to sum plus 2. That will be 1 plus 2 plus 3 plus 4. Okay. 1 and 2 and 3 will be 6 and 4. 4 plus 6 is equal to 10. The output from the program is shown here. Contents of AL 1, 2, 3, 4, sum is 10. The program begins by creating a collection of integers next to array is called and it obtains the array of integers. Then the contents of that array are summed up and total is displayed. There is something interesting. Collections can store only references, not values of primitive types. But autoboxing makes it possible to pass values of type int to add without having to manually wrap them within an integer as the program shows. So what is the example of autoboxing? What is the advantage? Like we have seen right now. What it did? Autoboxing made it possible to pass values of type integer. So what is the add function here? This is the add function. Okay. So in that add, you are adding the integer elements. These are the primitive type elements 1 and 2 and 3 and 4. Okay. Here you are passing what? A wrapper class integer. And here you are passing each element as primitive type int. So you no need to convert this primitive type to this integer wrapper class directly because of auto boxing. It is converted directly to integer and then it is stored to the array list AL. Okay, so that is the interesting thing. Autoboxing causes them to be automatically wrapped. In this way, autoboxing significantly improves the ease with which collections can be used to store primitive types. Okay, so autoboxing advantages we have seen. Then we are moving after array list. The second type is linked list class. We are moving to the linked list class extends abstract sequential list and implements the list, DQ and queue interfaces. So what you have to remember is linked list extends abstract sequential list and implements three interfaces: list interface, the DQ interface, and queue interface. Linked list is a generic class linked list E, where E specifies the type of object that the linked list will hold. There are two constructors: linked list default constructor builds an empty linked list, and then linked list collection extends EC builds a linked list that initializes with the elements of the collection C. Because linked list implements the DQ interface, you have to access. Because linked list implements the DQ interface, you have access to the methods defined by DQ interface. Okay, so all the methods defined by DQ interface you have to implement in the linked list. For example, to add the elements to the start of the list, you can use add first or offer first. To add elements to the end of the list, you can use add last and offer last or offer last. And to obtain the first element, get first or pick first, you can use over here. To obtain the last element, use get last or pick last. To remove the first element, use remove first or poll first. Remove the last element, use remove last or poll last. Now we will understand the linked list by using the example linked list demo. So here we have created linked list of type string. It will hold the elements of type string. Then add elements to the linked list. To add linked list ll dot add f b d e c z a, and at 1 you are putting a2. Okay, so it will be f a2 b d e CGA. Original contents of linked list. Remove the elements from the linked list F and 2 and contents of 2 LL of deletion. String value get and set a value. String value is equal to linked list dot get to. You are fetching the elements and then storing it to value, and then linked list dot set to value plus change. So this is the concatenation operator we have used, and at the location 2, here from the index 2 we are getting the value, and at that value we are putting the new value plus change. So linked list after change we are displaying. Okay, A2 F B D E C G, A2 D E C G after deletion. Okay, F is deleted, B is deleted, A2, D, E and C first and last is deleted, A is deleted, Z is deleted. Then after changing A2, D, E changed and C. So E element is changed. Because linked list implements the list interface, calls to add E append items to the end of the list as you calls to add last. To insert the items at specific location, use the add int E form of add as illustrated by the call add a1 a2. What did this function do? At particular location, add at that particular location new string or new element, whatever element, it can be float, it can be integer, it can be string, it can be boolean, and so on. But what is the importance of this method is add location 1, you will add this one. So whatever will be there present, it will be pushed to the next location, and all the elements too are pushed to the next location, and so on. The third element in linked list is changed by employing cause to get and set. To obtain the current value of an element, pass get the index at which the element is stored. Okay, so get will give the current value of the element for a particular index. To assign a new value, pass set at the index and its new value in the bracket. Okay, so get, for example, get 1 will give you the element at index 1, set, and value will put the element at the particular index 1. Then now we have seen array list, then linked list class. Now we will see the hash set class. Hash set extends abstract set and implements the set interface. Very easy to remember, only one class, only one interface. Extends abstract set and implements the set interface. It creates the collection that uses hash table for storage. Hash set is a generic class that has this declaration, class hash set E. Here E specifies the type of object that the set will hold. Okay, so E will be type of the object. As most readers likely know, a hash table stores information by using mechanism called hashing. Okay, hash table will store information after hashing operation is performed. In hashing, the informational content of a key is used to determine unique value called a hash code, and that hash code will determine the particular location's value. The hash code is used as the index to find out the value at the particular location or data at the particular location. Okay, so informational content of the key used to create a unique value hash code, and then again that hash code is used as the index at which data associated with the key is stored. Okay, the transformation of key to hash code is performed automatically. You never see the hash code itself in the hash table. Your code can't directly index the hash table. The advantage of hashing is that it allows the execution time of add, contents, remove, and size to remain constant even for large sets. Okay, execution time, that is time complexity, is reduced in terms of addition, contents, remove, and size operation to remain constant even if there are large set available. The following constructors are hash set, constructor default hash set collection extends C, initializes the hash set by using the elements of C. Then hash set integer capacity initializes the capacity of the hash set to capacity. The default capacity is 16. Okay, hash set integer capacity float field ratio initialize both the capacity and the field ratio, also called as load capacity of the hash set from its argument. Okay, so first one is what? It is default hash set constructor. Then collection initialized by using the collection elements. Hash set with the particular capacity, default capacity is 16. Otherwise, if your whatever capacity specifying, your hash set will be of that capacity. Then hash set capacity and field ratio initialize both the capacity and field ratio, also called as load capacity of the hash set from its argument. Field ratio must be between 0.0 and 1.0, and it determines how full the hash set can be before it is resized upward. Okay, for example, if the 50% if there is a bucket, okay, and what is your criteria? If the bucket is filled 50%, then you will take the new bucket to rearrange the water into new enlarged bucket. So same way, what it does, it determines this fill ratio from between 0.0 and 1.0 determines how full the hash set can be before it is resized upward direction. When the number of elements is greater than the capacity of hash set multiplied by its fill ratio, then the set is expanded. Okay. Number of elements are greater than the capacity of the hash set. For example, capacity of hash set is 3. Okay. And into if the fill ratio is 1.0. So 3 into 1.0 will give me 3.0, right? So that if your number of elements that you want to store in the hash set are greater than 3.0, your hash set is expanded. Okay. The constructor that do not take a full fill ratio 0.75 is used. Okay. For other 3 constructors other than this one. This is taking fill ratio, but this is not, and this is not. So these 3 constructors will take the fill ratio at 0.75. Hash set does not define any additional methods beyond those provided by its superclasses and interfaces. Hash set is very simple thing to understand. It is important that hash set does not guarantee order of the elements because process of hashing does not usually lend itself to the creation of the sorted set. Okay. So hashing is, we have already seen how we are doing hashing. Informational content of the key is used to determine a unique value, and depending upon this hash code or hashing value, we are creating the tables. Okay. So it does not guarantee the order of the elements because the process of hashing and generation of hash code does not usually lend itself to the creation of the sorted set. If you need sorted storage, then another collection such as tree set is a better choice. Okay. For sorted one, you use the tree set other than hash set. Now hash set example, hash set of type string is created. We are storing elements B, A, D, E, C, F and printing the hash set. D, A, F, C, B, E. D, A, F, C, B, E, depending upon the hashing value it is stored. Elements are not stored in sorted order and precise output may vary depending upon the system or your Java compiler. Okay. So after array list, linked list, hash set, we are going to see the linked hash set class. Okay. Now the linked hash set class extends hash set and adds no member of its own. Okay. So what is the class it is using? It is using the hash set class. The generic class that is declared as class linked hash set E, where E specifies the type of object the linked hash set will hold. Constructors parallel those in hash set. Okay, because it is extending hash set. Linked hash set maintains a linked list of the entries in the set in the order in which they were inserted. Okay. Linked hash set maintains what? A linked list of the entries in the set. Linked list and set combine the linked hash set. Linked list separate and hash set separate, and we are merging them together. So what is this? It is a linked list of the entries in the hash set in the order that they were inserted. And it allows insertion order in iteration over the set. When cycling through a linked hash set using an iterator, the elements will be returned in the order in which they were inserted. Okay. When you are using the iterator, you will get the object at same sequence when you have inserted into the linked hash set. This is also the order in which they are contained in the string written by toString when called as a linked hash set object. Now, to see the effect, now we will see, try substituting the linked hash set for the hash set. You will get the same values, those in those that sequence when you created the previous example. Okay, which is the order in which the elements were inserted. Then we will see for sorted order, we will see the tree set class. Tree set extends abstract set and implements the navigable set interface. It creates a collection that uses a tree for the storage. Objects are stored and sorted in the ascending order. Okay. Tree set extend the abstract set and implement the navigable set. So what it will use? It will use the tree for storage. Objects are stored in sorted ascending order. Access and retrieval times are quite fast, which makes tree set an excellent choice when storing a large amount of sorted information that must be found quickly. Okay, so tree set maintains the order. Sorted information you will get in the tree set, and large amount of data you can store in sorted order, and it can be found out quickly. And it is generic class. Its declaration is class tree set E. E specifies the type of objects that the set will hold. Following constructors are there: tree set collection C, tree set comparator super E comparator, tree set sorted set E SS. The first form construct an empty tree set as a default constructor that will be sorted in ascending order according to the natural order of its elements. The second form builds a tree set that contains the elements of C. The third form constructs an empty tree set that will be sorted according to the comparator specified by comparator. Comparators are we will see in future. The fourth form builds a tree set that contains the elements of SS, that is sorted set. Okay. Now we will see the tree set. Tree set of string is created. Tree set dot add C A B E F D. Okay. So you will get the sorted order A B C D E F. Because tree set stores the elements in a tree, they are automatically arranged in sorted order. That is the advantage of tree set. Because tree set implements the navigable set interface, which was added by Java 6, you can use the method defined by navigable set to retrieve the elements of the tree set. Okay, so all functions defined by navigable set interface are available over here. For example, assuming the preceding program, the following statement uses the subset to obtain the subset of TS that contains the element between C and F. Okay. So what is C? C is inclusive in that tree set and F is exclusive in that tree set. Okay. Output is C, D and F. Now we will you can experiment with other methods of navigable set. Then you can use them at home. Priority queue class. Priority queue extends abstract queue and implements the queue interface. It creates a queue that is prioritized based on the queue's comparator. Okay. So what is the priority queue? It creates a queue that is prioritized based on the queue's comparator. Priority queue is a generic class that has this declaration class priority queue, where it specifies the type of object priority queue will hold, and these are dynamic growing as necessary. Priority queue builds an empty queue. Its starting capacity is 11. Okay. Priority queue integer capacity builds a queue that has the specified initial capacity. Okay. Priority queue integer capacity comparator builds a queue with a specified capacity and a comparator. Okay, so there are the constructors in this page. Priority queue starting capacity is 11. Priority queue integer capacity builds a queue that has the specified initial capacity. Priority queue integer capacity comparator super E comparator builds a queue with the specified capacity and comparator. Priority queue collection extends EC. Priority queue extends EC. Priority queue sorted set extends EC. The above last three constructors create queues that are initialized with the elements of the collection passed in C object. Capacity grows automatically as elements are added. or in all the 6 constructors. If no comparator is specified, then the default comparator for the type of data stored in the queue is used. When no comparator, default is used. So you have to remember just like this. The default comparator will order the queue in the ascending order. The head of the queue will be the smallest value, and then the greater value, and at the last we will have the greatest value. Okay. However, by providing a custom comparator, you can specify a different ordering scheme as you want. When sorting items that include a timestamp, you can prioritize the queue such that oldest items are first in the queue. Okay. So whoever is oldest will have the greatest priority. That is the first priority. Then after that old one, whoever is coming will have the second priority, and so on. You can obtain a reference to the comparator used by priority queue by calling its comparator method. Okay. So the reference will be got by comparator super e comparator. It returns the comparator. Natural ordering. If the natural ordering is used for the invoking queue, null is returned. Although you can iterate through a priority queue using an iterator, the order of that iteration is undefined. Okay. So you are using the iterator to iterate in the priority queue, but that order of that iteration is undefined. Okay. To properly use a priority queue, you must call methods such as offer and hold, which are defined by the queue interface. Then next class is array dequeue class. Java 6 added the array dequeue class, which extends abstract collection and implements the dequeue interface. Okay. For all the classes like array list, linked list, has set, linked has set, priority queue, etc., etc. What you have to do when I am going to explain each and every class, the first line is added over here. What class it is extending and what interface it is implementing. Just create a table. Okay. For example, array list class. In for the second column, give the title as extends. For the third column, give the title as implements. Okay. In the first line for array list, in the extends column, give the class name that it extends, and in implements column, give the interface name that is implements. It adds no method of its own. Okay, so that by using the table that you have created, that table will help you to understand and remember which class is extending which class and which class is implementing which class. Array dequeue creates a dynamic array and has no capacity restrictions. The dequeue interface supports implementations that restrict capacity but does not require such restriction. Okay. So what is the function of array dequeue class? It creates a dynamic array and has no capacity restriction. Okay. Still, dequeue interface supports the capacity restriction implementation, but this does not require such restriction in this case. Array dequeue generic class array dequeue E, where E specifies the type of object stored in the collection array dequeue. Array dequeue defines the following constructor. First is default constructor, builds an empty dequeue with starting capacity is 16. Array dequeue integer size builds a dequeue that has the specified initial capacity. Then array dequeue collection extends E. C creates a dequeue that is initialized with the elements of the collection passed in C. The capacity grows as needed to handle the elements added to the dequeue. The following program demonstrates the array dequeue by using it to create a stack. Okay. Whenever the capacity is needed to increment, it grows to handle the elements added to the dequeue. Now we will see array dequeue example with a string object over here. A, B, D, E, F. We are inserting like a stack. Array dequeue dot push A, array dequeue dot push B, and so on. Popping the stack while array dequeue dot pick is not equal to null. We are popping and displaying the element. Output is FEDBA. So whoever is going first will come out last, and whoever is going last will come out first. So what is the output over here? F, E, D, B and A. Okay. Enum set class. Enum set extends abstract set and implements set. It is specifically for use with the keys of enum type. It is generic class that has this declaration. Class enum set E extends enum E. Here E specifies the elements. Okay. So it extends abstract set and implement the set. It is specifically with keys of enum type. And generic class with declaration class enum set E extends enum E, where E specifies the elements. Okay. E must extend enum E, which enforces the requirement that the elements must be of specified enum type. Okay. Enum set defines no constructor. It uses the factory methods shown in coming table. All methods can throw the null pointer exception. Copy of method and range methods can also throw illegal argument exception, and all other methods will throw null pointer exception if there is any. Off method is overloaded a number of times. This is the interest of efficiency. Passing a known number of arguments can be faster than using var parameter to reduce the time complexity when the number of arguments is small. When number of arguments are small and limited, so that instead of using var parameter, known number of argument can be passed. Accessing a collection via iterator, you will want to cycle through elements, that is using iterator. If you want to display each element, one way is an iterator, which is an object that implements either iterator or the list iterator interface. Iterator enables you to cycle through a collection, obtaining or removing elements. List iterator extends iterator to allow bidirectional traversal of the list and the modification of the elements. Okay. So these are the methods. Static E extends enum set all of, creates an enum set that contains the elements in the enumeration specified by T. Static E extends enum set creates an enum set that is comprised of those elements not stored in E. Static E extends enum set copy of enum set creates an enum set from the elements stored in C. Static E extends enum set E copy of collection E C creates an enum set from the elements stored in C. Static E extends enum set E none of class E T creates an enum set that contains the elements that are not in the enumeration specified by T, which is an empty set by definition. So now we will see iterator and list iterator. Iterator and list iterator generic interfaces. Interface iterator E, interface list iterator E. E specifies the type of object being iterated. The iterator interface declares the methods shown in the table. The methods by list iterator are also shown in the table. Operations that modify the underlying collection are optional. Remove will throw unsupported operation exception when used with the read-only collection. Various another exceptions are possible. So now we will see how to use iterator. Before you can access a collection through iterator, you must obtain 1. Okay. So first of all, you will have the collection. Each of the collection classes provides an iterator method that returns an iterator to the start of the collection. By using this iterator object, you can access each element in the collection, one element at a time. In general, to use an iterator to cycle through a contents of the collection, we will see the steps. Okay. So what you have to do, to iterate. First of all, what you need to have? You need to have a collection. Okay. And each of the collection classes provides an iterator method so that you can iterate from the start of the collection. You can access each element, one element at a time, like a for loop. For integer I is equal to 0, I less than 5, I plus plus. Likewise, you can access one element at a time. And to cycle, you have to follow these steps. Obtain an iterator to the start of the collection by following the collections iterator method. Set up a loop that makes a call to has next. Have a loop iterate as long as has next returns true. Okay. First of all, you have to have the iterator object so that you can start from the start of the collection. Then create a loop that makes call to has next. Unless and until there is next element next available, that is has next is not equal to false, you will iterate. Like integer I is less than 5. When I is equal to or greater than 5, your loop will terminate. In this case, whenever your has next is returning false, your loop will terminate. Within the loop, unless and until has next, get the element by using next. Okay. Void add e object inserts object into the list in front of the element that will be written by the next call to next. Boolean has next and returns true if there is a next element, otherwise return false. Boolean has previous returns true if there is a previous element, otherwise return false. Next returns the next element or no such element exception is thrown if there is not a next element. Okay. So this way we have completed some interesting topics related to collection interfaces. Okay. So in the next video we will see more related topics related to collection framework, and after that we will start with the practical one. Okay, so meet you in the next session. Thank you so much.